Have you ever wondered what are all these neural networks that everyone is talking about and were too afraid to ask? Well, fear no more. By the end of this video, you will be able to understand what is neural network, its working and application. If you have opened your browser in the last couple of years, you must have seen the expression neural networks a couple hundred times. In this video, I will explain you some context on the domain and on the thing itself. You won't become the world expert in this field in the next 5 minutes, but you will get through the non-trivial onboarding stage. You will also learn some buzzword to impress the family, teacher and friends at the dinner table, especially if you follow the video through the end. So, what is machine learning? To understand neural networks, we first need to understand what is machine learning. And to understand machine learning, let's talk about the human learning first, or classical programming. In classical programming, I, the developer, need to understand the aspects of the problem I am trying to solve and to know exactly what all the rules are to make it to the solution. For example, let's say I want my program to know the difference between a square and a circle. Then one way to handle it is to write a program that can detect corners and then apply to the count the corner. If my program sees 4 corners, then this shape is a square, and if it sees no corner, then this shape is a circle. In machine learning, when facing the exact same problem of telling apart circles and squares, we would design a learning system that would take as input many examples of shapes and their classes, square or circle. We would hope that the machine learning will learn by itself the property that tell them apart. And then, my friends, once the machine learning has learned all these properties, I can give it a new image of a circle or a square once it hasn't seen before, and it will help hopefully classify it correctly. What is neuron? A neuron in the context of neural network is a fancy name that smart people use when they are too fancy to say function. A function in the context of mathematics and computer science. It is a fancy name for something that takes some inputs, applies some logic and outputs the result. More to the point, a neuron can be thought of as one learning unit. Therefore, we need to understand what is learning unit. In the context of machine learning, then we will also understand the most basic building block of a neural network, which is called the neuron. To illustrate, let's say I am trying to understand the relationship between the number of a word in a blog post and the number of words people actually read from that blog post. Remember, we are in the machine learning domain where we learn from the examples. So I collect many examples of word count in the blog post denoted by the X, and how many words people actually read in those posts Y, and I imagine there is some relationship between them denoted by F. However, the trick is that I just need to tell the machine, the program, the sort of what is the relationship. I expect to see, for example, a straight line, and the machine will understand the actual line it needs to draw. What did I gain here? Next time I want to write a blog post that has X words in it, the machine can apply the relationship F it found and tell me how many words I can expect people to actually say read Y. So a neural network is, well, if a neuron is a function, then a neural network is a network of functions, meaning we have many such functions, such learning unit, and all their inputs and outputs are intertwined and they feed each other. Neural networks, the never-ending story, as this field is literally exploding. The amount of new and high-quality content coming out every minute is impossible for any human to follow. Oh my god, do you think there will come a time when humans can build an artificial intelligence that will be able to keep track of human advancement in the AI domain? Coming into this field, the first thing to know is that nobody knows everything. So feel comfortable where you are and just keep being curious. The working of artificial neural networks, also known as neural network, are computing systems that are inspired by the biological neural networks that make up animal brain. An artificial neural network is built from a network of connected units or nodes known as artificial neuron, which are loosely modeled after the neuron in the human brain. As seen in the above image, a neural network is basically divided into the three layers: input layer, hidden layer, and output layer. The input layer brings the initial data into the system for further processing by the subsequent layers of artificial neuron. The input layer is the very beginning of the workflow for the artificial neural networks. Before learning about the working of the hidden layer, let's first understand what are weights and bias in our neural networks. What are weights in the neural network? Weights represent the strength of the connection between the units. A weight can reduce the importance of the input's value or increase the importance. A weight near zero indicates that a change in the input has no effect on the output. Negative weights indicate that increasing the input will reduce the output. So, in a sense, the weight determines how much influence the input has on the output. Significances of the weight in a neural network. Neural network predicting if the image is of a cat or a dog. Assume we want to train a model that can tell whether an image is of a cat or a dog. First, we will train the model with images of a dog. Now, the recognizable feature of a dog are the features that distinguish a dog from a cat, can be its eyes, ears, nose, and so on. Example of a neural network trying to predict the image of a dog. Assume, for example, the dog has a distinct nose and that the input for the weight range from 0 to 1. So to give the nose more weight, we assign the connection colored in blue a weight of 0.6 and the other features such as the ears and the eye a weight of 0.2. I hope this example has helped you understand the significance of the weights in the neural network. What is bias? In neural network, the activative function takes an input x multiplied by a weight w. By adding a constant, for example, the given bias to the input, you can shift the activation function. Bias in a neural network is analogous to the role of a constant in a linear function, where the constant value effectively transposes the line. In the absence of the bias, the active function input is x multiplied by the connection weight w0. In the bias scenario, the active function input is x times the connection weight w0 plus the bias times the connection weight for the bias w1. This calls the active function to shift by a constant amount b multiplied w1 hidden layer. Finally, now we can understand what happened inside the hidden layer. Once the weight are passed through the hidden layer, two specific operations take place. Number one is summation of weights and the input. In this step, we basically do the following. Let's say our output is y and our input is x and the weight is w. Y equal x1 multiplied w1 plus x2 plus multiplied w3 and so on. The equation here we also add bias. Now you know what is the importance of bias and why do we add it. Number two, applying activation function z at y. After that we apply activation function. Let's say here we apply the sigmoid activation function, which is represented by z equal 1 divided by 1 plus e to power minus y. So the value of y from the equation 1 will be passed in the sigmoid activation function. Z equal 1 by 1 is e to power minus y, which will give us the value between 0 and 1. If the value is less than 0.5, the neuron will not activated, and the value is a 0.5, the neuron will get activated, as seen in the dog image prediction example before. Output layer. The output layer is the final type of the layer. The result or the output of the problem is stored in the output layer. Raw images get passed to the input layer and we receive output in the output layer. I hope you like this short video on the neural network was helpful. Do share it with your friends and the colleagues. Although the study of human brain is thousands of years old, the first step towards neural network took place in 1943 when Warren McCullough, a neurophysiologist, and a young mathematician, Walter Pitts, wrote a paper on how neural networks might work. They modeled a simple neural network with the electrical circuits. In the 1949, Donald have reinforced the concept of neuron in his book, The Organization of Behavior. It pointed out that neural pathways are strengthened each time they are used. In the 1950s, Nathaniel Rochester from the IBM Research Laboratories led the first effort to simulate a neural network. In the 1956, the Dartmouth Summer Research Project on the artificial intelligence provided a boost to both the artificial intelligence and the neural networks. This stimulated research in artificial intelligence and in much lower level neural processing part of the brain. In the 1957, John von Neumann suggested imitating simple neural functions by using telegraph relays or the vacuum tubes. In the 1958, Frank Rosenblatt, a neurophysiologist of the Cornell, began work on the perceptron. He was intrigued with the operation of the eye of a fly. Much of the processing which tells a fly to flee is done in its eye. The perceptron, which resulted from this research, was built in the hardware and is the oldest neural network still in use today. A single layer perceptron was found to be useful in classifying a continuous valued set of inputs into one of two classes. The perceptron computes a weight sum of inputs, subtracts a threshold, and passes one of two possible values but has a result. In 1959, Bernard Woodrow and the Marcian Hoff of Stanford developed models they call Adeline and the Madeline. These models were named for their use of multiple adaptive linear elements. Madeline was the first neural network to be applied to a real-world problem. It is an adaptive filter which eliminates echoes on phone lines. This neural network is still in this commercial use. Marvin Minsky and Seymour Papert proved the perceptron to be limited in their book Perceptron Progress on the Neural Network Research, halted due to the fear, unfulfilled claims, etc. Until 1981, this caused respected voices to critique the neural network research. The result was to halt much of the funding. This period of stunted growth lasted through 1981. In the 1982, John Hopfield presented a paper to the National Academy of Sciences. His approach to create useful devices, this was like cable, articulate, and the charismatic. In 1982, US-Japan Joint Conference on Cooperative Competitive Neural Network, at which Japan announced their fifth generation effort, resulting United States worrying about being left behind. Soon funding was flooding once again. In 1985, American Institute of Physics began what has become an annual meeting, Neural Networks for the Computing. By the 1987, the Institute of Electrical and Electronics Engineers IEEE First International Conference on the Neural Networks drew more than 18,000 attendees. In the 1997, a recurrent neural network framework, long-term, short-term memory, was proposed by Shimi Duber and Hochreiter. In 1989, Jan LeCun published gradient-based linear applied to document recognition. Several other steps have been taken to get us to where we are now today. Neural network discussions are prevalent. The future is here. Currently, most neural network development is simply providing that the principle works. This research is developing neural networks that, due to the processing limitations, take weeks to learn. Neural networks are widely used in different industries. Both big companies and startups use this technology. Most often, neural networks can be found in all kinds of industries, from e-commerce to vehicle building. So let's take a look at some examples of neural network application in different areas, mostly in e-commerce, finance, healthcare, security, logistics. E-commerce. This technology is used in this industry for various purposes, but the most frequent example of artificial neural network application in e-commerce is personalizing the purchaser experience. For instance, Amazon, AliExpress, and other e-commerce platforms uses artificial intelligence to show the related and recommended products. The compilation is formed on the basis of the user's behavior. The system analyzes the characteristics of certain items and shows the similar ones. In other cases, it defines and remembers the person preferences and shows the item meeting them. As for more complicated applications of neural network in e-commerce, there is a very interesting startup called Pixel. This product is developed to help sellers save the budgets on photographers' services. There is no need to organize photo sets as the special algorithm automatically makes the picture of the clothes worn by the models. All is needed is to do the resize of the image of the item to 64 by 64 and get the result. Finance. In this industry, there are neural network applications for fraud detection, management, and forecasting. Let's look at some examples. A great example of neural network finance application is SAS Real-Time Decision Manager. It helps banks to find solutions for businesses issue. For instance, whether to give credit to a certain person, analyzing risk and probable profits. As for financial forecasting, there are plenty of the solutions that predict the exchange rate changes. For example, the startup Find Profit is the software that uses a neural network of deep learning for the giving forecast about the wide range of the financial instruments like currencies, cryptocurrencies, stock, futures, healthcare. It is very difficult to create and train a neural network for usage in this industry because it requires high accuracy. For many years, it seems to be a fantasy to use this technology for examining patients and diagnosing them, but finally it has become possible. IBM Watson is the most powerful artificial intelligence in this world. It took 2 years to train the neural network for medical practices. Millions of pages of the medical academic journals, medical records, and other documents were uploaded to the system for this learning. And now it can be prompt the diagnosis and propose the best treatment pattern based on the patient complaint and the anamnesis security. Neural networks are widely used for the protection from computer viruses, fraud, etc. One of the example is ICSP, Neural from Symantec. It protects from cyber attacks by determining by the bad USB devices containing viruses and exploiting zero-day vulnerabilities. Logistics. This industry needs a lot of management that is to be done manually by employees of many companies, but nowadays neural networks are capable of routing and dispatching. For example, Wise system is an autonomous system which lets a user plan route and monitor them, customize shipping routes in the real time with the help of the predictive features. One more solution is Forekites. This is the visibility program that works in the real-time mode. It helps to plan and monitor routes and predict the time of the delivery. So that is the end of the video. I will see you in the next video.
गेटसाइटमेंट को लाइक करें, चैनल को सब्सक्राइब करें और बेल आइकन को दबा दें ताकि इस जैसी अपडेट्स आपको मिलती रहें।